Okay. Welcome to session 2 for my favorite application of Python, data science. On the Moodle, we've got, I added some session code. So here I've got the session 2 code for sorting and grouping data. And we're also using this hotel analytics Excel file. So let's see. So for the session 2, and then this is the Jupyter Notebook. So last week we looked at basic pandas, data frame and series, selecting, adding, dropping rows and columns, reading, writing data frames. In the data set, in this hotel analytics data set, there were two raw tables of data. The first one was sheet down here, plans, and the second was actuals. So actuals is actually formatted very nicely. You know, it's formatted exactly the way that Python Pandas is. It was probably output by Python Pandas if I had to guess. Plans is less clean. I mean, it's more pleasing to the eye, but in order to work with this plans data, last week we used selects, dropping and adding to reshape that data to look like this, and then we saved it in the plans sheet separately in a separate worksheet, which looks like this. So today, and notice that this data, the plans, is actually aggregate. Well, it's not data. It's the planned revenue, room, bar, and food revenue for each room type per month. So the unit of analysis here for each of these pieces of data is a room type, by room type and by month. But our actuals data is on a different level. Our actuals data is by room type, but it's not by month. It's not even by day, right? It's actual reservations. So in the end, ultimately, if we want to compare the actuals to the plans, we need to aggregate our actuals data to the same. We need to aggregate it and group it by the same variables. So we need to take our actuals data here, and it does have the month and it does have the room type, but you know, these actual days stay and each ID, right? It's disaggregated by each reservation. So in order to compare our actual reservations to the plan, we need to take the actuals data and we need to aggregate it by room type and by month, and even by these different revenue types. Some of these are sums, some of these are counts, some of these are averages. Right? So when we're aggregating, for example, average of occupancy, right? Or we're not always using the same function. We're not always aggregating and summing. We might be aggregating and counting, or aggregating and averaging. And so this is what we're going to look at today. We're actually going to set aside the plans data frame that we created last week, and this week we're going to just deal specifically with the actuals data frame, and we're going to wrangle it mostly through grouping and aggregating, through grouping and sorting, and applying aggregate functions on it, so that we can reshape the actuals, and then next time when we come back, and we can actually merge these two. So we can reshape them and we can merge them, and they'll be on the same unit of analysis. So that's the plan for today. And so again, here's the actuals. This is what the actuals sheet looks like in Excel. So I don't have to reshape this file or manipulate it by hand before I upload it into Pandas. With this sheet, you'll recall I had to reshape it like this by hand before I could open it in Pandas, but this one is ready to go as is. So I'm actually going to close this out. So today we're going to look at actuals and we'll sort and group the data. And then next week we'll merge the plan and the actuals together. And that way we'll be able to compare. We'll have our that way we'll have in the same row, we'll have side by side the planned revenue and the actual revenue. And then we'll be able to make the comparisons and see, you know, how far off was the actual from the plan. So, okay, so that's kind of the roadmap for the next 2 weeks. Okay, so the first thing is to examine and format the actuals sheet. So I'll start by importing pandas. And then here, this is the same line of code from last time, but instead of, it's the same file, but now the sheet name is actuals, not planned. And I'm going to save this. And also the header is 0 because you'll recall in the Excel spreadsheet, there was a header. It was on the top row. So here the parameter is actually the row index. So if there is no header, then it's header equals none. But if there is a header, then it's whatever the index of the row is. So if it's at the top of if it's the top row of the document, then header equals 0 is going to grab the header from the top row of the data. And then we'll save this as a data frame actuals. So do that. It's running. Why is this taking longer than yesterday or last session? Because there were, like, how many rows were there? Do you remember? Something like 13,000 or 15,000, right? There were a lot of rows in there. So, okay, so here's the actuals. I can print it out. You can see that it did grab the headers nicely. We have the visit ID, the month, the room ID, room type, room price, loyalty status, actual days of stay. So here's everything. And you can see down at the bottom, you can see the data frame. It starts giving us row 0, 1, 2, 3, 4, and then these ... and then it gives us the last 5 rows. So the indices here are, you know, 13,581, 2, 3, 4, 5. And then it has the dimensions of the data frame here, approximately 13,600 rows and 13 columns. Okay. So you can also double check this by using this .shape attribute of the data frame. The data frame has the attribute shape, which will just output the number of rows and columns as a tuple. And another thing that I didn't show you last time, which is also helpful, because we have 13 columns, what's the data type of each of these columns? So what's the data type of visit ID? Integer, yeah, and room month and room ID, they're all integers. We hope they're integers. They look like integers, but in Excel, they might have been coded, they could have been coded as numbers, or they could have been coded as strings, right? And we wouldn't be able to tell that by looking at this, but it's really uncomfortable if you go and start doing mathematic operations, and then it says it kicks an error because you thought that 1, 2, 3, 4, 5 was the integer, but it was actually saved as a string, right? So this is another way to explore the data types of each of these, just to it's another attribute of the data frame called .dtypes, data types, and you run this, and it'll give you the data type of each of the variables as it imported it from Excel. And Excel did a great, I mean, Pandas did a great job. So everything is an integer except for 2 rows, right? Room type and concern description. And that makes sense because if we go and look up at the data, room type, these are strings, right? And concern descriptions are also strings. So that's fine. Everything else is in integers. So that's nice. This is actually very clean data. If this was not the case, if these were all objects or all strings, then we'd have to go back and recall, like in the first lecture, we specified what every single column, what the data type of every single column should be, and we cast it as we imported it. I think we used here this code here to force pandas to cast these variables as the data types that we wanted. But fortunately today, for actuals, oops, get out of my way. We don't have to do that. Okay, so we have all the data types we want. Okay, so let's jump right into it. Today we're going to talk about sorting and grouping. So first of all, I'm going to introduce sorting by single and by multiple criteria. And then we'll look at grouping, and we'll add sorting on, like we'll sort as we group. So just kind of we're gonna build up step by step. So let's first let's sort by room type. So again, you've got actuals. I like to just, when I explore the data, I like to just do this, you know, to explore the first couple of rows, because I don't want my whole screen taken up by, you know, showing me these like 10 rows or whatever. Okay, so for room type, that's the variable name. So let's so we'll use the sort by function. It's sort values, I think, in Python, in pandas, and you type in room type. Okay. So it's the function is sort values, and then you just put in the name of the column that you want to sort by. So this function is actually capable of much more complicated sort queries, but this is the most simple, this is the simplest format. So, okay, and then you can see that the room type here, right, is there's club room king deluxe, and then alphabetically comes first, and then superior king room comes last. Okay, so that's fine. What if we just want to get the unique? What if we just want to get the unique, the list of room names and just sort those? So we could do, so in this case, you could just isolate the variable. So this is going to return just the room type and then sort by those values. Let's see, is that going to do it? No, let me see. Because this is a series now. So let's see, sort for, maybe it's here. Okay, so here, this is what I'm trying to show you here is not only about the sort function. What I'm trying to show you is that in pandas, you can append things to the end. Right? So you can run a sort function, you can run a group by or agg function, and what that returns is a data frame, now sorted or grouped or whatever. And then at the end of that data frame, you can also now add selection, you know, you can add queries or subsets like on that. So this thing returns a data frame, and then yeah, and then you can add more code on the end of that to alter that data frame that was returned. Okay? Now you don't want to get carried away with it. You know, I prefer to kind of do things methodically. You do like one step and then save it, and then one step and save it. But you can kind of append these, right? And then here, so you still have so it's sorted. It took this sorted list, and then it's just isolating the variable room type, right? And then if you wanted, like, say you only want the unique list of names sorted, you could do the unique after this, I believe. Right. And now, but this is where it gets tricky, because up until this point, actuals.sortValues room type, that returns a data frame. right? But then this square bracket with room type, where you're isolating one variable out of the data frame, that's going to return a series, right? And that's why you saw the format for this is the format of a data frame, right? When it returns a data frame, this thing is not a data frame. That's a series because you've isolated one column out of the data frame, which is a series, right? And now if I use the function unique, right? Unique is not a function on a data frame. That's a function on a series. And so this is where things get tricky, and they are sorted alphabetically, right? Club Deluxe King Room, Executive Suite, King Suite, these are alphabetically sorted now, right? But if you wanted, let's say you have, say you add like room price. Let's see here. Yeah, I think you're right. Yeah. So now here I get a data frame and not a series because I'm asking for, this gives me a data frame. This is taking a subset of my data frame, the two columns, right? Room type and room price. And then I'm sorting values based on room type, right? And then assuming that the room price is the same for each room type, now I can drop duplicates, right? And that should give me a unique list. Right? And you can see here now, the Club Deluxe King Room, right, has 3 different pricing levels. Maybe these are at different months or something. And then the Executive Suite has 3 different prices, and here have 3 different prices. What if I want to sort this list first by room type and then by room price? Can I do that? So here I've selected two columns from the data frame, a subset of the data. And then here in sort values, you can also sort on multiple values using square brackets inside of the function. So if you, here you put in the square bracket room type and then room price. Okay, now those have been resorted. These are still sorted alphabetically, but now within each room type group, the prices are sorted from low to high, right? Now, you also have some other parameters in sort values. For example, now these are sorted ascending from smallest to largest. You can, sort values also allows you to add some additional parameters to sort, from descending order rather than ascending order. So let's look at, so I'll show you the function. So here sort values by, it's either a string or a list of strings, right? Which are the list of names to sort by. So we just use the list of strings. And here ascending is true. So it's in ascending order, but ascending can be a bool or a list of bool. Okay. So ascending can either take true, false, but if the values that you're sorting by is a list, then ascending also needs to accept a list. Well, it can either accept a single Boolean value, true, in which case so in this case, if you use a single Boolean value on a list of values that you're sorting, then it's going to sort both of those in ascending order. And if you say ascending is false, then it will sort both of them in descending order. Right now we're listing from in reverse alphabetical order from most expensive to lowest. Right. Now let's say we wanted to flip it. Let's say we want the names in alphabetical order, but we want these in descending numerical order. In that case, you have to use a list of Boolean values. So here, ascending, we're going to use a list, and we want room type to be ascending, and we want room price to be descending. So you choose so you make a vector, or in this case, a list of Booleans which correspond to the values that you're sorting on. So now room type is sorted in ascending order, and room prices are for each room type, they're sorted in descending order. What if I switch what if I switch the order of these? What if I do room price first and then room type? What's going to show up? If I just change the order of these, so now before I was sorting by room type and room price, now I'm sorting by room price and room type. How's that going to alter the result of the query? Start from. So here, when you do sort values as a list, as a list of column names, it does them. It's actually grouping them as it sorts. So it's going to sort by room price. So it's going to sort by room earlier. It's going to sort by room type first, and then within each room type, it's going to sort by number, right? So it's sorting on the first category and grouping them at the same time. And then when you move to the second one, it's going to use that as a secondary criterion within rooms of the same room type. Then it'll sort those. So it's hierarchical. So if we do by room price first and then room type, there's no guarantee that the rooms are going to be grouped, right? So the room names could be out of order if the price ranges of the different room types are overlapping. So we can look, right? So here, here we have room price by ascending order. So here we're listing the cheapest room from 130, 150, 170, 170, and you can see the room types are overlapping. That some king suites are cheaper than some superior, that the cheapest king suite is cheaper than the same price as the most expensive superior king room, right? And so here it's just sorting by room price first, and then this room type, where that comes into effect is here. If you have two rooms whose price is the same, in that case, it'll sort those in ascending order because that's what we specified here, right? So this isn't doing much work unless you run into rooms that are the same price, right? Now, also a few things to notice. The order of the sorting values has nothing to do with the order of the columns in the data frame, right? It doesn't matter that room type comes first and room price comes second. That's irrelevant. Right? The sorting values is going to go in order of the vector that you specify in the function. The second thing I want to point out is right now to simplify this, I'm adding drop duplicates at the end, right? Because this list would be a list of 13,600, right, if we sorted. But all I want to know is the unique pairing of room type and price. Right? So this is a strategy that's really common. Like if you're going to sort or you're going to do any kind of analytics on the full data frame, first of all, choose the relevant subset of data that you want to look at. Otherwise, you're going to get additional columns of data in there that could possibly screw up your, right? So if you only want to look at room types and prices, then just specify that initially, call out that subset of columns that you want to look at, and then sort these, and then, and then you can drop duplicates to kind of, so let's do another exercise, sorting exercise. Let's sort by revenue, food and beverage. So what might we, let's just look at the data first. Let's sort by month, and let's just say revenue beverage, okay? So what I want to know is just to get a sense of which months, like how do beverage revenues it's probably better to go on to grouping and then do this. I'm thinking. Well, let's just do this. Let's sort by let's sort by beverage revenue and room type, and let's just see if we can note any difference in like which room types have higher or lower revenue for beverages, right? So so how would we sort by beverage revenue and room type? What would be our first step here? So what columns do we want? Do you want the beverage revenue column first? It doesn't matter, but we can put revenue beverages, and they spelled it interestingly. So okay, and room type. Okay, so let's just look at that. That's just our revenue beverages and room type. So let's sort by. First, let's just sort by revenue beverages. It's going to bother me. Okay. So we do see some pattern, just even looking at the bottom five, the lowest five and the top five, right? The King suites have the lower. What do we remember? What were the more expensive? What were the cheapest rooms? So here's the room type and the room price, right? So the cheapest rooms are Superior King room and King suites, right? Those are the cheaper rooms. The more expensive rooms are the 1-bedroom suite and the 1-bedroom club room, right? So not surprising that lowest beverage revenues are going to be probably for these rooms. And if you're not spending a lot of money on your room, you're probably not spending a lot of money on, I mean, there might be a correlation there, right? So, okay, so these King suites, the beverage revenues are the lowest, and the 1-bedroom suites, the beverage revenues are the highest. What if you want to just kind of, right now, Jupyter Notebooks or Pandas is kind of just not showing you all of the data, right? They're showing you like the top 5 and the bottom 5, just so this thing doesn't blow up your screen, right? What if you want to kind of scroll through all 13,000? So you can do that. There's a feature in Pandas, rows. It's called like max row something, display.maxrows. It's this pandas.setOption display.maxrows. So you can copy and paste that. I'm just gonna put that here for now. So the default is max rows 10, right? And that's what we're seeing. We're seeing the top 5 and the bottom 5. But if you say none, does that do it? Nope. Was it? I forget. Let's see. I think it's none. Oh, yeah, PD. That's right. You're right. That's right. I aliased it as. Okay. Now it's going to take a minute to think. And it very generously, kindly, outputs the data set in this kind of scroll down box. So you can go in here, and now we can actually scroll down all 13,000. Right, so you can see, okay, now here the revenue hit $1. So we're still in King Suites, Superior King Rooms, right? You can scrolling, 2, 3, 4, 5, right? And then we can scroll all the way down, 105, 106, 107, all the way down to, ooh, wow. Somebody drank a lot of beverages there in the 1-bedroom suite, or a few expensive ones. All right, so on the high end, mostly you've got like 800, 700, 600, 500, but it drops off pretty quickly to less than 100. I would say the median is definitely below 100, right? Okay, so this is sorting. I'm gonna restore this to 10 because I don't want to blow it up every single time. So you can use sorting in combination with choosing subsets of data. You can use it in combination with dropping duplicates. You can sort on multiple criteria. You can vary whether each of those criteria is ascending or descending. You have a lot of power in specifying kind of queries, customizing sorting queries. But most of the data science that we want to do is not just sorting aggregate or sorting the entire data set. We want to get into grouping and aggregating, right? And that's where things get interesting. So first of all, there are a few ways to group and aggregate. When I say group and aggregate, we need to familiarize ourselves with aggregate functions. So here's a link here to some aggregate functions that you can do. These are 13 functions to aggregate in Pandas. 13 aggregating functions. So this is coming, everything that we're doing in Pandas is directly has some correlate in SQL, right? But whenever you group by, if you're grouping by, say you're grouping by room type, or you're grouping by month, or you're grouping by any variable, usually grouping is like you're usually grouping, and then you're going to apply some kind of an aggregate function to either that same variable or some other variable. So these are functions that you can do on grouped variables. You can if it's a numeric variable, you can, once you've grouped, you can calculate the average of those variables. You can calculate the sum. You can count them. You can count, standard deviation or variation or standard error. You can find the first or the last or the nth value in a list. The nth value, why might this be interesting? The nth value in a list. So this is an aggregate function. Say I give you 100 values and you want to find the nth value. Why might that be interesting? So this is it's a statistic that we do. It's a statistic on a vector of numbers, right? And the nth value, if it's the nth value is say the count divided by 2, right? Then that's the median, right? So the nth value, which is like the midpoint of the data set, that's the median. This is where you can calculate percentiles, right? So you can calculate like the 90th percentile or the 25th percentile or the 50th percentile, the median, right? So that's the value of this nth. And then you can find the minimum or the maximum. So these are all aggregate functions that you can apply after you've grouped. So so let's try this. So first, let's try counts. We've got count here. So let's take actuals, and we're going to group by. So here it works similar to sort. It works exactly the same as sort. You can either put in a single value and group by that, or you can put in a list of values that you want to group by hierarchically, right? So first, let's group by room type. And if I just enter this, you'll see it doesn't really return anything useful, because usually you're using group by in conjunction with something else, right? And the reason why it doesn't know how to do that is because, say you have 13,000 rows, and then you have 6 room types. Okay, now you're grouping by 6. So you're changing the dimensions of this data set from 13,000 to 6. But what are the other rows? I know what the values of the room type are going to be. They're going to be the names of each of the room types. But what about all the other variables? Like you're just compressing, 1 or 2,000 reservations for each room type into a single row. What value are you going to put in that row? Are you going to put in the count? Are you going to put in the sum? Are you going to put in the mean? Like what? So if you just export this group by, it's like it's halfway through and it's like, okay, and then what? What are you going to do? So let's try count. Okay. And this returns a very interesting and dangerous table. So we have group by room type, right? We have all the room types that we want here. And 2042 for Club Deluxe King Room, 2042, 2042, 2042. Why are these numbers all 2042? Yeah, so it applied count, except for the row that you sorted by, grouped by. For the row that you group by, it's just returning the unique value. But for every other row in the data frame, where you're applying this function count to every single row. So for Club Deluxe King Room, there were 2042 visitor IDs. There were 2042 months that were not empty. There were 2042 room IDs, prices, et cetera, et cetera. Here, concern description is 368 because remember, not every room had a concern. So this is the number of non-null concern descriptions for that room type for the Club Deluxe King. But the rest of these are 2042, which means that they have full data, right? But really, like 2042 loyalty status, 2042 actual days stay, this is not like so relevant information, right? If what we were trying to do is find out how many room reservations did we have for each room type, if that's what we wanted to count, then perhaps we could have just picked any one of these variables, right? So a better way to do this, if we just wanted like counts by room type, would be just like we did with sort, to pick the subset, right, of data that we care about. So we want room type for sure. And what else could we count to make sure to see how many reservations we're getting? Actually, any of these variables would be fine. Yeah, I think visit ID is like the most kind of sensible. But actually, any of these variables, as long as it have full data, would give us an accurate count of room reservations, right? But visit ID, this will give us the number of the count of visit IDs. Is it unique? Are these numbers, are these counts of unique instances or no? Not unique, right? Because month, we only have 12 months in the year, but it counted 2000, right? So it's just counting non-null entries. It doesn't care if they're unique or not. So, but we could, let's count visit IDs. Okay, oops, no. There we go. Okay, so this is what we actually want when we say count, right? We want each room type, and then we want the count of each visit ID. Okay. Now, what if we want to sort this by number of counts? So notice that visit ID here has been displaced. Right? I mean, it's up here, but we haven't. Okay, so here you can add the sort parameter onto this, and now it's been grouped by and sorted, right? So now we have room types by the number of reservations, right? In ascending order. Okay. So this is kind of the pattern. This is parallel to a SQL query. So in a SQL query, where you identify, first you select the variables that you want from the data frame, from this data frame. Then if you don't have any other parameters, then you can group by whatever. You include the aggregate function, and then you can also order by or sort values. So very similar to SQL query. Okay, what about, let's try a different function, the sum. So what would be, if I'm summing visit IDs, that doesn't seem to make a lot of sense because those are just arbitrary IDs. What would be something that I'd want to take the sum of? Let's see. Okay, so here's our data set. Which of these columns, let's say we're grouping by room type, what's that? Actual days stayed. Okay, yeah. So let's sum actual days stayed. So we'll take actuals. I want, which variables do I want? I want room type and what? And okay. So I'm just going to grab room type and actual days stay. Now I'm going to group by room type. And then I'm going to sum. Make sure that's a valid function here. So these are the actual days stayed by room type. And then I can also sort these by actual days stay if I want. Okay. So now we're starting to get into actually like useful summaries of data, right? This is moving towards like the analytics that we want to do, right? Because eventually what we want to do is take this actual data and make it look like the plan data, right? So we want to group by month and room type and revenue type and make sure that the aggregate functions are appropriate. Right? So we're building up to that. Okay, quickly, let's go back to beverage revenues and find our maximum and minimum beverage revenues. Right. So here, let's do it by okay. Actuals, room type. And what was beverage revenue? Revenue beverages. Group by room type, max. Okay, so these are maximum beverage revenues by room type. What if we want to find, let's do maximum beverage revenue for each month, right? Let's see if there's like some kind of a seasonal effect. So what columns do I need? I want to look for maximum beverage revenues by month. Month and beverage revenues is fine. I don't care about room type right now. And then I'm going to group by month. And then do I want to sort by beverage revenues, or do I want to, I guess I could do that. Let me grab that display rows. Okay. So here it's sorted by beverage revenues. So the cheapest month, the beverage revenues are lowest in May. They're also low. It looks like these are winter months, right? So they're lower in the winter, higher in the summer, right? And then in the middle, we've got spring and fall, right? You could also sort them by month, right? And maybe so we can see in the winter it's around 600, 500, and then it goes 700. But in the spring you get in the 700s, and then in the summer it almost doubles, right? And then you get in the fall and it's not quite halved again, or in the 900, 800 range, and then back down to 600, 700. Right? So here you can see like a seasonal effect for revenue for beverages. Right? Let's see, does food revenue have a similar pattern? So we're going to look at maximum food revenue. So this will be revenue food, if that's the right. Revenue food, yeah. So similar pattern or not? 1,200, like 1,200, 1,500, 1,300. Higher in the summer. Yeah, a little bit of a seasonal pattern. Okay. All right, so what we've done here is we've grouped and aggregated using a single group on a single group and single functions. So let's step it up a little bit. Let's do single group, but multiple aggregate functions. Okay. So for example, let's take this example with the suppose we want maximum suppose we want minimum and maximum beverage by month. Okay. So I'm still grouping by month, but now I want to see not only the maximum, but I also want to see the minimum. So now I'm going to have, how many columns of data do I need? So I only need month and, oh, sorry, this is beverage, right? I only need month in this, and I'm only grouping by this. But now max or min is not going to be enough, right? Like I can do max to look at the max, or I can do min to look at the min. But if I want to see max and min, right, then I'm going to need something else. So this is where we use this agg function. So this list of functions here, mean, sum, size, count, these are simple functions that you can use if you just want to do one operation on one or more columns. But if you want to do different types of operations, either on the same variable or different variables, then you need to use the agg function. So here, the agg function. So here, I'll put this in the. So the agg function can take a string, or it can take a list, or even a dictionary of access labels and function names. Okay. So first of all, let's use the agg function with a function, or yeah. So here we can use agg. Let's just use min. Do that. Did I spell it wrong? I think I misspelled the misspelling. Oh, did I not put an S in? Okay. So first thing that you can put into this agg function is actually the function name of one of those simple functions like min or max. And notice that it's grain, right? Because Python, because it's a defined term in Python, right? So that's one thing you can do. But that's just, we could already do that by just writing like max, right? So that's nothing special. So the next thing you can do is put in a string or a list. So you can put in a string of the function name, or you can put in a list of functions. So let's put in a list of functions because we want min and max. Okay. So if we do this, if you do it this way, then you're going to group by month, but everything else in this data frame that's not the one that you're grouping on, you're going to apply all of these functions to all of these additional variables. Right? So let me show you what I mean. If I add in revenue food, so here's beverages, and then here's revenue food. Right? So it's multiplicative, right? I've got two variables here and I've got two here, so it's going to apply the min and the max to this, to beverages, and the min and the max to food. So here, if you do it this way, whatever summary statistics you put in here, it's going to apply for every single variable. You can imagine this would get really messy if you didn't specify the subset, right? If you just ran this on the entire actuals, remember you have like 13 columns of data, and it's going to group by month. And then for those other 12 columns of data, it's going to apply every summary statistic to all 12 columns. It's going to be, you know, so, okay. So here you can start getting some interesting summary statistics, right? So we could add in, we could add in beverages, food, room price, and then the total, like min, max, min, max, min, max. What's another, why don't we just add in, for the heck of it, average, or I guess mean. So let's add in the mean. Not defined. Maybe it needs a function. Okay, so remember here you can either put in, you can either put in the function or the string function name. So it's not, it wasn't recognizing mean, but if you put it in as a string, it'll recognize it. So it can be a list of functions and or function names. It can be mixed, right? So here's a mixed, this is a mix of strings of function names and the function names themselves. We'll put this in. Okay, so now we have the mean beverage revenues, the min, the max, the mean, min, max for beverage and food. All right. Okay, now again, you can sort, right? You can sort this as well. And what do you want to sort by? Let's sort first by month. And then let's sort by, oh, I don't know. Actually, I don't even know how to call these. We have to label these if we want to sort by them. So I'm not going to do this right now. Okay. What if, so one more variation. This is minimum average by month. This is minimum average, minimum, maximum beverage and food by month. Okay, suppose you just wanted average beverage and maximum food, right? Okay, I know it's a little ridiculous, but just to illustrate, how would you do that? So we don't want everything. We want to be able to specify, or let's do this more like, what would you want for by month? We want room counts. Let's do room counts. No, average days. No, total days. Some of days. What was that variable? Actual days stayed. Yeah, some of actual days stayed, and maximum food and beverage. And actually, let's do this by room instead. Okay, so here we'll have a room type. We need what was days stayed? Actual days stay. Revenue beverages and revenue food. Okay, we're going to group by room. Okay. Here now, if you do this, so we wanted, what do we want? Count for actual days stay, and then min and max. So, but if you do this, you're going to get yeah, some. I think I keep forgetting the it's lowercase. Okay. Right. So it's giving us the sum, min, and max for each of these three variables, but I only want the sum here and the min and max for these two, let's say. Okay, so how can I do that? So you can use a dictionary. So this is the last kind of it. Here you can use a dictionary of access labels to functions. So the key, remember dictionaries have keys and values. The key is going to be the variable name, and the value is going to be the function or the list of functions. So and notice that the value can be a function or a function name or a list of such. Right? So to construct this, let's say we'll call this summary stats. It's a dictionary, and for actual days stay, what did I want? The sum. Okay, and for beverages, what did I want? Okay, max. And let's say I want the min and max here. So here I could put max if I want, or I can put list max like this. Okay. And then for the last variable, food, I also want the minimum and maximum. Okay, so then I run that. So this is just creates a dictionary like this. Sum, min, max, min, max. Okay, so then I take the summary stats, and then here in ag, I just put in that summary stats. Okay. And now it's produced the subset of analyses that I wanted, right? So for actual day stay, I wanted the sum. I actually want to add into here the visit IDs. Count. It's not making it green, so I'm just going to put it into the string, hopefully. So by room, count of reservations. Okay. And I can just, if I want that, I want to move that up to the front. Okay. Right. Okay. So this is, I mean, we're still grouping on one variable, right? But this shows how using the ag function, either with a single variable or list of functions, or a list of functions, or even a dictionary, that you can customize any kind of summary statistics you want for any subset of variables in your data frame. Right? It's completely customizable. It only takes a lot of patience to make the dictionary. So a lot of times I won't do this. A lot of times I'll just do, like, the max function. Okay, check that out, the min function, and just kind of do a table for each one. But if you do want something kind of nice, and if you're doing this regularly, say you're in a company and you're getting in a data set every month, and then your boss wants you to make a nice report out of this, and if the data format's the same and the report format is the same, then you might actually spend some time to customize this, and then export this as a table, right? Which you can then put in like a report or a PowerPoint or whatever, right? So if I was just doing like exploratory analysis on a new data set, I wouldn't bother, right? But if you need kind of a standardized output and you're going to be doing this again and again with a similarly structured data set, then it might be worth it. So okay. So the next step though is, remember in our plans data set, on the plans data, this is actuals. In the plans, we weren't just aggregating by month or by room type. We're aggregating by month and room type. And then we had several summary statistics for each room type, by each room type, by each month. We wanted the sum of food revenue, the sum of beverage revenue, the sum of room revenue, and the sum of total revenue, right? So how do we aggregate on multiple groups? So, and it's going to be the exact same pattern that we saw with sort values. Instead of putting in a string, you're going to put in a list, and it's going to do them in order. Right? So that's the next, that's the final kind of complicating step here. So now we're going to group and aggregate on multiple groups and using multiple aggregation functions. So let's say let's just start with something simple like room counts by month and room type. Okay, we just want to see number of reservations per room type per month. So here it's multiple groups and just one aggregate function. So we can do actuals. What columns will I need to do this? I definitely need room type, and I need month. And then what variable have I been using to do the room counts? We can look at the data set again. I almost always just kind of look back at the data set and see. Yeah, room ID, visit ID, any of these are, I think we're using visit ID because it's a unique number. Not that it matters when you're doing counts, but just out of habit. So, okay, so, and maybe, yeah, the order doesn't matter here too much, but then, okay, so then group by. So now I want to order by month and room type. So here I'm using group by, and then inside of the function, I'm going to put a list of the variables that I want to group by. And the order matters here. Right? If you order by group, room type, and then month, it's going to give you something different than, well, they'll be the same, but they'll be ordered differently. Okay, so group by, and then I want count. Is it count with an S or no? No S. Okay, I can use count here, and it's going to the only variable it's going to apply count to is visit ID, because that's the only variable that's not being grouped. It's going to apply count to any variable that's not in the group, which in this case is visit ID. So, and let me go back up here and choose my. For now, I'm just going to say none because, none of these are going to give me like, 13,000 rows. Okay, so I've got by month first and then by room type. Right? And then here's the count. Okay. You could change the order of these, right? We could do room type first and then by month. So here, now you've got the room type and the month. These are the counts. So any seasonal effects? I mean, I don't see like a summer. I mean, if it drops a little bit in the summer, maybe, I don't know. These ones definitely drop in the summer. Lower, but then drop in here in the winter too. Highest in the fall for this, highest in this. Yeah, anyways, so okay, so that's those are counts. What else might we want to do by month and room type? What are some other stats by month and room type? Let's start building up to the data set that we actually want. So remember, so this is the data that we're trying to eventually compare the actuals to, right? Although we kind of reshaped it, we reshaped it as this. So we've got the room type, and then by month here, and then we've got these summary statistics. So I guess these are the 4 summary statistics that we want to calculate. So let's do that. So let's calculate, first let's calculate like maybe each of these. Sum of, so the sum of beverage revenues. So let's do sum of beverage revenues by month and room type, since that's one of the things that we needed. So we need room type, month, and revenue beverages. And we're going to group by room type and month, and we want sum. Okay. Okay, good. So let's go for the whole thing now. So we want sum of beverage. So we want sum of total, room, food, and beverage revenues by month and room type. This is kind of ultimately what we're trying to get at, right? Fortunately, it's sum. So, but I want to add into this count of room reservations, count of reservations. And let's add in our average, or no, our, yeah, and sum of, what was it, days total? Total days reserved? Yeah, sum of actual days. So okay, so what variables do we need for this? We need room type and month for sure. Then we need, I'm going to include visit IDs here for the count of reservations. I'm going to need yes. I guess just do this. I need revenue room. Revenue food. Revenue beverages. Revenue. Okay, this is getting too messy for me. So what I'm going to do here is I'm going to call this analysis columns. And I'm going to specify the columns that I want. And I've told you this before, like kind of, or I've mentioned this before, like how I kind of, if the query is getting too complicated, you know, if possible, I like to summarize it in pieces. So the columns that I want to include in this are room type, month, visit ID, room revenue, room food, revenue beverages, revenue total, and also actual days stay. Okay, so that's okay. So those are the columns that I want to include in my analysis. Let's do the dictionary, right? So I want for summary statistics, I'll copy and paste this one that we did before. For summary stats, I want the count of the visit ID. I want the actual days stay sum. I want revenue beverages sum. Let's see, what do I want them? I want them in this order. So, and I can just might give me an error. I don't know. So I want the visit ID count, the actual days sum, stays revenue, room, food, beverages sum, and revenue total sum. Will let me do that? Okay. And why am I writing it this way? It's just easier for the human eye to see, right? It's just as a list. So I just kind of write it like that. And so now I have my analysis columns, I have my summary stats, and now I'm ready to assemble the query. So it will be actuals, and in the columns here, I'm going to put the list of columns that I want to analyze, right? And here I'm going to group by, so here I didn't make a separate list because I only have two, it's fine. I want to do room type and month. Right? And then I'm going to use agg function on this dictionary. Revenue food. Oh, it's capitalized. Okay. So all right, there we go. So this is everything I wanted, right? I've got the room type, I've got the month, I've got the visit ID, actual days stay, revenue room, revenue food, revenue beverages, revenue total. Okay. Couple of things I want to point out here. We're almost done. I want to take this table, format it just a little bit, and export it. And then next week when we come, we'll take this table and the plans table, and we'll merge them together. Before we do that, two things need to be fixed. First of all, we have not talked about indexes or indices, as they're called, different pronunciations. But when, if you look at room type and month here, notice that they're in bold and that the rest of these are not. And also notice that room type here is not filling all of these cells, right? And what Pandas is doing, if you look at just at the regular data frame here, actuals, you also see that out here there's an index that's in bold. Right? So Pandas assigns an index, is assigning an index to this table, and it's just kind of automatically numbering these, right? These don't mean anything to us. I mean, we can use them as like to identify the unique rows, right? But when you aggregate, when you group by, Pandas is actually taking these values that you're grouping by room type and month, and it's using those as the new indices for this data frame. So if you look at the shape of this data frame, we have 6 room types times 12 months. What is that? 72? 72 rows, right? And how many columns? 1, 2, 3, 4, 5, 6, 7, 8 columns. But if you look at the shape of this, it's reporting 6 columns, not 8. Right? And the reason is it's not treating room type and month like columns of data. It's treating them as indices in this data frame, 2-dimensional indices, right? So, but that's fine when we're just like kind of surveying the data, but that's not going to work for us. Well, I mean, it's easier. I'll show you next week. It's easier if we convert these to regular columns of data and not as indices. So that's the first thing that we have to do, is we have to tell pandas, hey, thanks, but no thanks. I don't want to, like, I don't need these as indices. I'd rather just have them as rows of data, right? And you can add your numeric index on the left here, right? So there are uses for those indices, but next week when I show you merge, it works easier without the indices. So first thing we want to do is remove these as indices, and the second thing is we want to relabel these columns, right? Because this column is not visit ID, right? It's the sum of visit IDs, right? And this column is not room revenue; it's the sum of room revenue, right? So you can, if you keep the same column name, you might get confused with the disaggregated data and the aggregated data. So we want to make sure that we know these are summary statistics and not individual values. So those are the 2 things we need to do. We need to reformat or can remove the indices from the rows, and we need to relabel the columns. So to do this, first of all, we haven't saved this as a separate data frame yet, right? So I'm actually going to go down here and just save this as a new data frame, actuals ag, okay? Or call it actuals aggregate. And then I'll just do that. Okay, and now we have here. Now actuals ag is the new data set. Okay, so we have to prepare the actual ag data frame. So I guess I'll put this here. Okay, so I create a new data frame, and now I'm going to first I want to remove the indices. From rows. So I think this is I think it's drop, or no, it might just be drop. Yeah, let's I forget. I'll reset index. So if you reset index here, you have to specify the level. Okay, and I just want to remove all levels by default. So I don't want to drop them. I don't want to drop them. I just I want to remove them as indices, but keep them as data. And then I'm going to do this in place true. So so level is none. That's fine. Drop is false. That's true. In place is true. So let me I think I'll just do drop indices. Well, we'll reset. Well, let's do in place false now just to see if it. Did I spell it wrong? I'll reset index. Okay. Okay, and that's exactly what I wanted, right? Now room type and month are variables, not and I have a new index. Right? So that's fine. But this is not saved to this, right? This is just outputting that. So if I want to save that, I need to do the in place equals true. So okay, so now it's done that. So that's task number 1. And then I want to replace columns. So oh, and this sometimes it creates this new index here. Oops, we don't want to do that. This yeah, I ran this again and it removed the old index and made that a variable and create a new index. So you can't run this multiple times. So I have to go back and, okay, so yeah. But if you rerun this line now, if you rerun this, it's gonna remove that index and save it as a variable, which we don't need, and then create a new index, right? And it'll keep doing that. So you have to be careful not to. Okay. So column names. What do I want? What do I want to replace these with? So I'll call these room type. I like to use column names that don't have spaces in them, just out of habit, because not every computer program like handles column variables as strings very well if they have white space. So room type, month. What was this? This visit ID was actually what? Counts, reservation counts. Days stayed. Okay, well, we can just let's call this reservation counts. Days stayed counts or total. I like counts because, okay, and then revenue room total or sum, revenue food sum, revenue revenue room food beverage. Now I can finally spell this correctly. Sum. What was left? Revenue total. Revenue total sum is also kind of confusing. The sum of sums. Okay. And let's just make sure that's fine. Okay, so these are our new column names. And then here we'll just actual zag columns is the attribute name, right? If we call that, those are the column names. And if you set that equal to this new list, it's going to just assign that list as the new attribute, and which will effectively change the column names of the data frame. So now if we look at actual zag, right. So it's clean now, right? This is exactly what we wanted. It's the room type by month with and all of these are summary statistics, right? We have the counts of rooms, the days stayed, the sum of, so these are counts, these are sums, right? And later, if you wanted to, oftentimes you'll calculate summary statistics from summary statistics, right? So for example, like the total revenue sum divided by if you wanted to calculate average revenue per stay, right? You would take this number here, this total revenue sum, divided by revenue counts, right? And you could add that in as another column now that we have this, right? So some of these summary statistics come directly out of the raw data. Some of them are like kind of second order summary statistics that you calculate. They're statistics of statistics. But for now, we'll just leave this. And then here, I'm just going to output this actual ag. So in my project folder, I have the original raw data, which is hotel analytics. I have plans, which is the formatted one that I reshaped from last week. I'm going to save this one as actual ag right now. So I have the data frame .toXL, and then the formula, the file name .xlsx. Just, oops, not defined. Where are you not defined? Actuals, there's an S. Okay, so here it's just saved it here. We pop that open. Right. So this is our actual revenue data. And if we open up plans, this is our plan data. Now you'll notice that these files are not shaped the same way, right? In the actuals file, the room type and the month are all, everything is in the column, right? But here for actuals, the months are still in the rows, right? So it's reshaped. So if we want to reshape this file to look like this file, we're going to have to invert this and take the month and like invert it. So that's what we're going to do before we can join and actually compare these. So next week, what we're going to do is we're going to reshape this file to be the same shape as this file. And then we're going to merge them. And then we'll start calculating some summary statistics, right? Comparing like for each room type and month, the total revenue with the planned revenue for that room type and month. And then we'll be able to see, did they meet their goals, or is it falling below, or did it exceed expectations, right? So that's where we'll pick up next time. Okay, so I'll throw this up on, I'll throw all this code and the new files up on the Google, on the Moodle, and then I'll see you guys next week. Any questions from Zoom land? Adana, Adil, Jalen, we're all good? All right, I'm gonna stop recording.